So I think having that reliability is definitely key, and definitely not being able to kind of push the limits at every second, not like a drag racing application where you got 8 seconds and if the engine blows up at 9, you're fine.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Hannah Westbrook, who is a senior engineer and group lead at Honda Performance Development. Also previously worked for around 9 years at Motec USA as an applications engineer. And obviously in this industry, it is very male-centric. We don't come across too many females in the industry. So it's a breath of fresh air to have Hannah on the podcast and talk about her experience and how she got involved in this industry that is so male-dominated. Now, Hannah's probably about the closest thing we've had to a rocket scientist on this podcast. She has a degree in electrical engineering. We find out what that degree actually means in real terms. She's also done a minor as a mechanical engineer as part of her degree. More recently, Hannah jumped into a postgraduate degree at the University of Cranfield in Advanced Motorsport Mechatronics. Definitely a bit of a mouthful, and if you're not quite sure what that means, don't worry, we're going to dive into exactly what's involved during our interview. Now, before we do jump into our interview with Hannah, just a quick introduction for those who maybe aren't aware of HPA and who we are. We're an online training school. We specialize in teaching people how to tune factory and aftermarket engine management systems, build performance engines, construct reliable quality wiring harnesses. We also cover topics on race driver education, race car setup, and even fabrication. Relevant to our discussion with Hannah today, specifically around her work, reverse engineering late model factory cars, we've got our CAN bus decoded course. Now, CAN bus is very prominent in just about any late model factory car, and the CAN bus allows all of the different electronic components in the car to communicate over a single 2-wire bus. This has become a very powerful method of transmitting and receiving messages between components, and it also really allows a lot of flexibility in the equipment that you're going to fit to your car. Because CAN bus is a standard communications protocol, what this means is that we can pick and choose between the different elements. Maybe you want to run a Motec dash, maybe you're using a Haltech ECU or any other combination that you could imagine. You can also reverse engineer some of the CAN messages from the factory ECU, maybe the factory ABS, etc., and use that information in your ECU or dash. However, in order to be able to do this, you obviously need to understand CAN, understand how the messages are made up, how to read them, how to transmit them, and how to decode them. And that is where our CAN bus decoded course comes in. If you want to learn more about CAN bus and how to set up these devices in a modern motorsport electronics application, then this course is perfect. We will put a link to that course in our show notes. And as a podcast listener, you can use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. Again, we have a link with that coupon code in the show notes. All right, enough with our introduction. Let's get into our interview now. Welcome to the podcast, Hannah. Thanks for joining us today. And as we always do, we want to get started by learning a little bit about your background, how you got interested in the automotive industry, cars in general, and then maybe we'll dive into your education as well. So yeah, what can you tell us, Hannah?
Sure. Thanks for having me. I would say I didn't grow up with cars or racing or anything like that. My family isn't involved in racing at all. I'm the second engineer in my family, but the only one that's in the automotive or motorsports industry. So I really got into racing on my own. In high school, I kind of started watching Formula One, which it was interesting, and actually started watching a little bit of NASCAR as well. And then really when I went to college, I thought I was going to be electrical engineer. I really thought I was going to do wireless technology at first, and I joined the FSAE team at the university, and kind of really fell in love with the whole fast-paced atmosphere, the idea of putting something on a car and actually seeing it go down the track versus kind of being behind a desk and kind of having that 9-to-5 job. This is a little bit more exciting and a little bit more fast-paced, and I really enjoyed that. So I'd say that's where I got the start for.
let's take one step back there. You said you didn't really have any family interested in motorsport or racing. And it's quite unusual for someone to just develop that interest in and of themselves. So were you surrounded by friends at college that were into racing, or is this literally just you developed this just off by yourself?
So when my dad, when he was working, he's also an electrical engineer, but he was in England for work and actually got a tour of the Red Bull F1 facility and came back just raving about it. You know, how cool it was, how interesting it was, how interesting the technology was, how kind of groundbreaking some of the things they were doing were. So I think that was like, oh, okay, so let's check out what this Formula One thing is all about. So, you know, kind of started looking into that, getting into that, and then kind of went from there. So I think that was one of the first things that really turned me on to kind of this whole racing world.
Okay, great. I mean, F1 is definitely seeing a resurgence of popularity these days, I think mainly thanks to the Netflix Drive to Survive series, which gives you that background, you get a bit more involved. So yeah, interesting that you sort of got involved in that back then. In terms of your college, your university degree, you've sort of mentioned your Formula SAE there, which I want to dive into. But in terms of the education, what were you actually doing there at university?
I'm an electrical engineer, so that was my major. And then I was also getting a mechanical engineering minor. I started at the University of Lehigh, which is in kind of eastern Pennsylvania. And actually, after 2 years, I transferred to the University of Pittsburgh and finished out my bachelor's degree there.
Okay. Give us a little bit more insight. Let's go a bit deeper into this. I mean, obviously, electrical engineering is a degree. There's a pretty big hint in the name, but let's go a little bit deeper. Yeah, what does that degree actually mean? What skills do you learn? And as importantly, I guess, what industries does that set you up for work in once you come out of that degree?
Yeah, so I mean, electrical engineering, I think, is a really broad term. There's so many things that fall under electrical engineering that you can learn in college and you don't always learn in college. For me, you know, we did a lot of signal processing, signal development. You do a lot of programming, so C-based programming or MATLAB, Simulink type style of programming. You do a lot of kind of theoretical antenna design is one of the classes you can take, at least at the University of Pittsburgh. You know, there's lots of different types of electrical engineering. So you can really go almost anywhere. Because if you think about where electronics are in our world right now, you know, they're in your cell phones, they're in your computers, they're in your watches, they're in racing, they're in everything. So the development of the electrical engineering program, you know, you can learn all of this circuit board design things if you want to. You can also go programming. You can also go to, you know, more of the physical design side of things. So there's really no limits to it. It's really what's limiting is depending on what the university has to offer at each university, I'd say.
Okay. So obviously, as you mentioned, opens you up to just about an unlimited number of potential industries. From what you've just described as well, am I right in assuming you, as doing that electrical engineering degree, you kind of have to pick the areas of electrical engineering that you want to specialize in yourself, or do you have to do an across the board a little bit of everything?
It's a combination. I'd say the first 2 years you have your basic classes. You know, everybody takes, you know, physics 1 and 2. Everybody takes chemistry, for example, which is interesting. But everybody takes the basic circuit design class. Everybody takes the basic programming class. And then really your junior and your senior years, you can get a little bit more picky with what ones are interesting to you. So you have certain ones you can pick from, but you don't have to have a set exact number of classes that you have to take, you know, your senior year, I guess.
Okay. Now, as you got into this, are you already in your mind thinking of how you're going to apply this for a career in the motorsport industry, or did you have other aspirations and dreams when you first started down that path?
I think my freshman year, just being new to engineering classes in general, I think I was pretty open to different areas. You know, my dad was a wireless engineer, RF engineer, so that was interesting to me. I really thought about doing kind of sound engineering. I thought that was really interesting to me as well. And then when I started getting a little bit more into race cars, I was like, no, this is it. Done. Sold.
It's a disease. You can't get rid of it once it's in you. Okay, and you've also got this minor aspect of your degree in mechanical engineering. So again, I mean, obviously, hint in the name, but give us a bit of a deep dive on what mechanical engineering actually entails.
Yeah, so that's for me was everything from designing boxes to understanding the stresses in different materials to doing thermodynamics to, kind of all that broad range of anything that has to do with materials, and anything that could be in manufacturing of different components as well, which for me was a really cool tie-in because when I got to my first job, I had a little bit, I wouldn't say a ton because it's only a minor, but that little bit of extra knowledge on understanding kind of how mechanical components at least somewhat function instead of being a little bit more in the dark and just knowing about kind of electronic side of things. So having those two, I think, was a really beneficial thing to have.
I mean, it does appear to be a nice synergy between those two elements, particularly when you want to apply them in anything that involves race cars. Now, as part of your time at college, you've mentioned that you're also involved with the Formula SAE team. So we have had a couple of guests in the past talk about Formula SAE, but for those listeners who maybe haven't heard those podcasts, can you give us a bit of a rundown on what Formula SAE is?
Yeah, so it's a university-based team. Basically, universities across the country, across the world, will develop and design a race car every year. And then at the end of that year, usually in May, they'll go to a competition. This competition is typically in Michigan. But what it is you're being judged on, your defense of your design. So you'll actually be quizzed by different judges on, why did you pick this gearbox? Why did you pick this engine? Why did you pick these tires? Why did you pick, this control strategy? So everything on the car has to be defended by you and your group. You also get to actually race the car. So you actually get to do, figure eights. You get to do an autocross course. There's an endurance aspect to it. So you actually get to try everything from the theory behind why you designed a race car the way you did, all the way to actually building it throughout the whole year, testing it, validating it, retuning it, adapting it, and then taking it to an actual event where you have to defend what you did, explain, why the choices that you made were correct, everything from budgeting to the actual engineering questions as well. And then beyond that, you actually get to take it out and drive it. So it's kind of a really cool concept to go from start to finish, and you have to do it basically within a year.
Yeah, it sounds like the absolute dream. I was always absolutely devastated that the university I attended here in New Zealand didn't have any involvement with Formula SAE, and was always jealous of anyone who had access to that. In terms of your involvement, what were you actually tasked with? And I mean, maybe also give us a bit of a rundown on how many people are involved in a Formula SAE team.
Yep. So that's a really big kind of range because you'll get small teams that are made up of 5 people who just put their heart and soul into developing this race car, and they don't have a very big budget. They don't have a ton of resources, but they've really been able to kind of scrap together what they have and actually get a car to make it to competition. And then you have other teams, like especially ones that come from Germany, typically that have 40, 50, 60 students that are all working on this. So you have this really big range of different universities and different capabilities and different resources, and they all get to this competition. And obviously the more resources you have, typically the more you're going to be a little bit more prepared and you have a little bit better components. But you get some surprising teams that are able to show up with less budget or less resources and still able to perform really, really well at the competition. So
Yeah, it's an interesting point there. On face value, I would have thought too many people, what's the saying, too many chefs in the kitchen, it can actually make it harder to get a result. So 50 or 60 people sounds like an absolute potential disaster waiting to happen, versus maybe a smaller tight-knit team where you haven't got maybe 5 people sort of vying for a design on one particular element. Or am I wrong there?
No, so you're definitely right. And I think it's all comes down to how the team is organized. So I actually, after I graduated, I became an FSAE judge. So I actually got to see the other side of the table. And when I was being a judge, you get to quiz the students on what their design is and understand the team aspects. And me, I came from, Lehigh University was a very small team. There was maybe 10 of us. And then when I went to Pittsburgh, there was maybe 15, 20, I would say. So a little bit bigger, but we definitely weren't one of the larger teams. But I think what it really comes down to and why you see some of these teams that are small that succeed is because they've got really good organization. They've got everybody understands what's going on the car. So everybody can understand if somebody can't do this, then you got somebody else you can ask for help, so that makes it a really good dynamic. But the big teams, You also have you get more people that are interested in the marketing, which means you can pool more money for your resources to be able to buy components or to machine better components or more expensive materials. So and then you have people, you do marketing, you've got people in the business aspects. So you've got people that are organizing, people that are managers. So I think it depends on how you organize the team as to which is beneficial. And there's plus and minuses to both for sure.
Okay. I'm interested in diving a bit into the budget there. You just mentioned sort of the marketing element. How are these financed? Is it a case of the university puts up a budget, of the students personally putting in some money of their own, or is it a case of going around local businesses and seeing what you can rustle up?
I've actually seen all of it. So I've actually seen one student sell his own plasma to pay for the car. That was actually something I saw as a judge when we were talking to them afterwards. But they were so diehard; they just wanted this car to make it to the track. I've also seen teams like that will work with local businesses that are doing machining, so they'll get them to machine certain parts of the car for them, or they'll get them to machine certain components. So they'll work with local businesses to kind of get that support. So either they'll get discounts or they'll get some kind of a free component. Or you put their sticker on the side of the car, or you rep them in your press release, or kind of things like that, all the way to the university puts in some money as well. So the university can give you $5,000 budget, they can give you a $50,000 budget. It really depends. And I think some of that comes down to how you perform that year for the next year on what they're kind of going to give up. And the same thing for businesses too. If you're your local team, they might be just willing to throw you some extra stuff. But if you're performing well and they get to see, you get a little bit more publicity, then they might be willing to give you a little bit extra too. So I think it's always changing every year, kind of what you can get, who you can ask for. And it's really about like reaching out to the community, reaching out to other vendors, and then seeing what they kind of can provide and what you can provide them to make it kind of worth their while.
Yeah, that makes sense. So we have some involvement supporting a couple of the New Zealand-based Formula SAE teams, and I know there's a couple of companies here in New Zealand that I believe could be mistaken, but I believe are sort of donating their autoclaves to make the carbon monocoques and things like that. So other what would normally be quite a high ticket price item suddenly becomes a little bit more manageable for a modest budgeted team. In terms of your specific team, could you dive into your role? What were you doing?
So the first 2 years at Lehigh University, I was definitely a little bit less involved. I think the senior members there really wanted to keep control of everything, so they wouldn't really let the kind of freshman, sophomore year members to do it quite as much. So I was doing a lot more helping in the machine shop to machine some of the molds for the monocoque. So you were doing some kind of machining. I would do a little bit of cam work to try to develop some of the molds as well, with a lot of their help because I was brand new to that aspect. I would get to do like a little bit of the help in the wiring area. Once I transferred to the University of Pittsburgh, I got to really dive into more of the electronic side of things. So I actually got to do some of the wiring harnesses on the car. I got to help with the dyno wiring harness. I got to do some of the actual setup. My team was lucky enough to have Motec equipment in the car, so I got to do some of the actual setup for the data analysis systems and some of the actual like data analysis itself using the i2. So I was actually able to do a lot more work. And then my senior year, I really helped develop the wiring harness. I graduated in December, so I only got a half semester, but I actually got to go back with the team to the competition the following May after I'd been working at Motec for a couple months and still support kind of the quizzing by the judges and the design aspect and watch them in the racetrack and help out where I could.
It sounds like it's really played nicely into your roles in the future, which obviously we'll get to. Before we do, just again in terms of those who really don't know anything about Formula SAE, talk us through what the engine is or engine options. What are your limitations? What can you choose?
Yep. So there's a limitation on the CC of the engine. But when I was there, and this is back in 2008 to 2012, so quite a while ago, it was a maximum of 700 cc's. But you could do everything from a single cylinder to 4 cylinders if you wanted to. There's also a limitation on the restrictor for the intake. So you have an actual limitation on the size of the restrictor that you can run, which means obviously you have limitation on your airflow. So picking your engine is really kind of open. You didn't have to have an exact certain engine, but obviously there's trade-offs in which one you want to choose on. If you want lightweight, do you want a heavier but more powerful engine? And how does that work with the rest of your team? And how does that work with your chassis design? And how does that work with your electronics and kind of everything else?
Okay. In terms of the build of the car to the competition point, you've mentioned you're sort of working across a year. First of all, is this in your own time? This is outside of your actual university papers?
Yes. Yeah, this is all external times. This is, nights after you finish your classwork or finish your classes. This is weekends. This is early mornings, definitely late nights, kind of spent on the side. You can do like your senior design project. You can have some involvement in like your FSAE team. So that's an option. But the majority of it is kind of after school, at least for
Okay.
University of Pittsburgh. There are schools that your entire senior year is just the FSAE team.
Okay. I mean, particularly, I just wanted to sort of get to the point. If you've got a busy schedule anyway and you're studying for exams, etc., it's going to be tricky to also juggle your time and put enough into the Formula SAE project to actually make that competitive. So it's a sort of testament to those who are dedicated enough to get it across the line in the end. That 1 year period, so I mean, I can only imagine that if you were starting with a completely clean sheet of paper and not a single component built, that is a hell of a task, particularly based on what we've just talked about, that you're doing it essentially after hours. Mm-hmm. Is that the case? Are you literally starting from scratch, or is this always an iteration of what the last year's car was?
I think that, again, it's pretty dependent because the rules are so open. You have my university, for example, we reused some of the components from the previous year, and there's only a certain amount of the components you're allowed to reuse. So you can reuse, one or two things, but you can't reuse the entire car. That's banned through the competition. So you can reuse a little bit. But again, with teams, I think it depends on exactly what your resources are. So if you have a good log of data from the previous year, if you have a good CAD system, if you have a good way to pass down information to the next year students, then I think you end up with a lot of that knowledge transfer. And I think the goal is to have the seniors teach the juniors, teach the sophomores, teach the freshmen, so that by the time the freshman is a junior, they're really in depth with 3 years of knowledge on kind of how a car was built previously. So they kind of have a good head start. However, there's universities throughout the US that it's a senior year project for the FSAE team. So they start from scratch every year with no knowledge of what the previous team did.
Wow.
So that to me is way more impressive because that's just unbelievable.
Oh, absolutely. I mean, throughout motorsport around the world, it's almost always an iterative approach of looking at the performance of the last product and where its strengths and weaknesses were, and then focusing on developing those weaknesses and improving it rather than starting from scratch. And often maybe you'll completely miss the mark because you've got no data points to start from. In terms of your results when you're involved, can you tell us how did the car go?
My first 2 years, we would say mid-pack. There's about 120 teams that typically show up to competition. So I'd say we were somewhere between like 40 and 60. So we weren't amazing, but we were able to finish the racing elements. We did okay in the design judging. We were able to defend our examples, but we weren't, we didn't think through a lot of the things that we had chosen to do. And I think that was a part of down to the small team and also part of down to the knowledge transfer that we just didn't really have there. Throughout my junior and senior year, we definitely moved up. My senior year, we actually made it to design finals. So you have your design set up, and then you get chosen to go in design finals, which is typically about the top 8 to 12 teams, depending on how they kind of see it. And that's when the judges kind of give a little bit more in-depth look into your car. They ask you kind of the more in-depth questions to get a little bit deeper and see where your knowledge kind of level, where your cliff is on terms of that. So that was really exciting to make it into the finals.
Can you go a bit deeper into this sort of the design element and defending your design? Can you give us maybe a couple of examples of what sort of questions the judges are asking and what sort of defense are you required to come up with?
Yep. So for me on the electronic side, a lot of the questions I got asked were on the data acquisition side as well as the wiring harnesses. So they'll ask you questions, anything from kind of why did you choose this gauge wire? Why did you choose this this layout? What was the reason behind running these sensors? What was the advantage that you got from running these sensors? Okay, open up a data log file, show me you're actually running these sensors. Okay, explain to me what these sensors are doing. And so it's everything from, start ground up from why did you wire it this way all the way through to how are you actually using your data? Because you have teams that, they'll buy 25 different sensors, but they never look at any of the data. And so that's really a problem because it's, why did you put that on there? Because at that point, it's just extra weight. You're not doing anything with that data. So I think that's the kind of more in-depth questions that they start to ask. And then once they push that level of, okay, you're actually using data. Okay, how much are you using data? Which data are you using? are you giving this data back to the vehicle guys, the vehicle dynamics guys, to improve the way that the springs are working? Are you passing this information back to your aero team so that they understand what downforce you have? So is it just you're collecting a bunch of data and you hope that someday you're going to do something with it, or are you really using this to kind of tune the setup on your car?
Some really interesting information I want to dive back into there. And I mean, obviously this really relates to anything in the motorsport world, just not just Formula SAE. And I think there's always a temptation, obviously, if budget allows, to just put more and more sensors on the car. And I think particularly if you are only just getting started with data acquisition, less is definitely more. And there's that temptation to have all of these flash sensors and really, A, not understand the data that they're providing, and B, combination of A as well. If you don't understand the data, obviously you can't do anything with it to actually improve it. But I see this time and time again. So we've got a couple of data analysis courses, and we really sort of start by sort of teaching like less is more, focus on the core channels. And then once you're confident with those and you're actually using them well, then you can expand out and start adding in some of these more sort of exotic sensors, I guess, if you like. Coming back to your comment on wire gauge, because this is quite interesting to me as well. What sort of wire gauge are you using? Obviously, you go to a smaller gauge wire and you've got the benefit of a lower weight, but there's also a mechanical strength element in there as well. So I'm sort of interested, what's your choice there?
Yeah, so I think for sensors, typically we went for like 22 gauge, which obviously is a little bit overkill. You can definitely get away with smaller gauge wires. It's not drawing a lot of current. You don't need necessarily that bulky wire in terms of what its capabilities are current wise, but it does have that strength, like exactly what you're talking about. And when you're in an FSAE car and you've got a bunch of college kids that probably aren't too, I'd say, gentle with,
yeah.
Yes, exactly, with taking things apart, and you're in a rush, especially when you're on track or things go wrong and everybody wants to get back out there, then you kind of have to use that little bit thicker gauge wire. It also does kind of streamline it a little bit because, again, with resources, if you've got access to 10 spools of 22 gauge wire, then you use that because it's what you have, because you don't want to buy a spool of 22, a spool of 28, a spool of 30, and use all those different ones, because if you can get donated 22 gauge wire, or you can get that for bulk, so it's a little bit cheaper, then okay, this is going to help for pricing as well. So I think that for sensors, obviously when you go to fuel pumps and other kind of more current intensive, you're going to step that down to, depending on what the rating is of the sensor, up to 18, 16, 14, all the way down to the battery cable, which is much thicker wire.
Yeah, and there's levels to that, and I mean, obviously understanding the current that's going to be in a particular circuit really is the key element there. But when you're talking about sensors there, the current is minuscule, so the gauge of the wire isn't really there as a requirement to support the current flow. It's that balance. And the other element that I think is important as well, 22 gauge is sort of my go-to, and I'm sort of deep in a wiring harness for one of our internal projects at the moment, which is almost exclusive 22 gauge. But when you're dealing with motorsport grade connectors or sensors that have the likes of an Autosport connector on them, well then you can get away with the smaller gauge wire. But if you're using sort of production level OE style sensors, or the cheaper sort of motorsport sensors where you've got the little rubber seal that goes around the conductor before you put it into the connector body, those don't really fit well once you start getting beyond sort of 22 gauge. Basically, you're not going to actually get any sort of crimp onto the conductor, so it's no longer sealed from moisture. So that's another consideration.
Yeah, definitely. I mean, the cars definitely run in the rain. They'll run in the wet. If you're on the EV team, which there wasn't EV when I was in university, but they do have an EV competition now, they'll actually make you do a rain test. So you actually have to run the car underwater to make sure that everything's safe. So that for sure is a consideration, because if you get moisture in the back of anything, it's gonna have potential corrosion problems or potential issues with shorting, and all of that's definitely a big concern.
Okay. All right, let's move on from Formula SAE. So you get out of college and move into an actual job. How did that all sort of pan out? Obviously, you've already mentioned that you moved to Motec, but how did you get that position?
Yep, I had a friend at University of Pittsburgh actually do an internship with Motec about a year before I graduated. He came back from it just, kind of raving about all the different things he got to work on, all the different projects that they do, and said, "Listen, if you want to do electronics and you want to do motorsports, this is the place you need to apply to." So I actually emailed who would be my future boss and just said, "Hey, I'm interested. Here's my resume. Would love a chance to come down and talk to you guys if you're looking for people." I got a phone call about 2 days later, I think, and said, "Okay, here's a quick kind of phone interview. It's like 10 minutes long." Asked me a lot of questions. I had no idea what the answer was, and then they flew me down anyway, and they interviewed me in September before I graduated in December. And a couple of days after they interviewed me, they offered me a position as an applications engineer. And then they said, while you're finishing your degree, would you want to come to a couple races and kind of get your hands dirty and see, what it's all about? I was like, yeah, sign me up. Yes, please. So I did that for a couple races before I actually started there.
All right. Well, let's start by defining the role. What is an applications engineer? What does an applications engineer at Motec do?
So an applications engineer at Motec is kind of a very broad term, because I think at Motec, you do kind of everything. When I first started, I did mostly, customer support. So you're talking to people on the phone, you're fixing their issues, you're helping them, calibrate sensors, you're helping them, calibrate things on their engine, calibrate the PDM, which is the power distribution module for the 12-volt lines, and then everything from there to actually, working on the wiring harness side of things. So working with the wiring harness designer to spec out systems for new customers. So everything from NASCAR to IMSA to anything else, and then beyond that, it's developing new things. So luckily at Motec USA, we are involved with Motec Australia, which is the main company that builds all of the hardware. But we also have RaceGrade, which is the sister company, and that is kind of Motec USA's way to develop kind of ancillary products to help what would you sell with a Motec product. So you buy a Motec dash, but maybe you need a side thermocouple amplifier, and so we've got one on the side. So then that can pair those two together. So it was really about developing kind of bespoke custom PCBs to do kind of small little add-ons for Motec devices. So you kind of get involved in everything.
All right. So just to clarify, the Motec, the main sort of company is Motec in Australia. They are the design and development company that produce all of the Motec product. Motec USA, as I understand it, is a separately owned company, and essentially purchasing product out of Motec Australia and selling it. But then obviously as you use the product, you start seeing potential avenues for other products. So this race grade product line, this is essentially products that maybe Motec Australia didn't want to develop themselves or didn't see a necessary market for, but Motec USA did. Is that correct?
Yep, that's exactly right. So yeah, it's basically, add-ons or within the US market for components that might be needed on, like, an IMSA race car that isn't needed in Australia for V8 supercars or for any of the other series that they're involved in. Then this would be, a product that would be made specifically for, a racing series, or specifically for a customer, or specifically for a car that maybe Australia doesn't have.
Yeah, okay. It makes sense. I mean, obviously every motorsport market has their own sort of subtleties and nuances of products that work or are needed versus others. So yeah, I totally get that. All right, so maybe talk us through the sort of life cycle of designing a product under that race grade name. I don't know what you are specifically involved with there, but how does that sort of process go from the concept inception through to actually developing prototypes, testing, and finally getting a product to market?
Yep. So I think it really depends on the product, because Motec Race Grade does quite a few different avenues. They have everything from like OEM adapters, which, for example, like the C7 Corvette adapter that they have, it takes the OEM harness and runs it through an adapter board, and then adapter board would go to like a Motec M182 ECU. And what that does is that allows the signals to be manipulated from the OEM side of the harness into a Motec M182 in terms of pinouts, in terms of maybe taking a little bit of the high side, low side outputs that are necessary for the OEM, but that you don't want to tie up M182 outputs for, so that you run them, on the board itself with a microcontroller and a couple, transistors basically, and you can turn those on and off, and you can do that, off of the M182 to free up space for people that want to run, twin turbos, and so they need a bunch of extra outputs, or people that want to run other sensors. So a lot of that kind of a market is, the first thing you need to do is you need to understand all the OEM signals. So what signals, what's the OEM pinout? Okay, so you have an OEM harness. What's the OEM pinout? What things do we need to control to make all of the other modules in the car happy? Because oftentimes, in 2016, it wasn't so bad. You would be able to take out an OEM ECU, replicate the CAN bus and the other signals that you need, and it would work okay. Now, as cars get more and more complex, you have more and more complexity and more kind of systems on the car, and different security levels on these systems. So taking an OEM ECU out of the car, once you do that, the body control module, the ABS system, everything else in the car knows about it. And if you don't replicate those signals exactly perfectly, it's not going to work. The car's not going to start because it's not happy. So when I was designing some of these boards, they were definitely a little bit easier because they didn't have all of that security complexity. So like the C7 Corvette board, for example, or some of the adapter boards that we did for Hayabusas for drag racing. A lot of those boards, they don't have that complexity on the CAN bus yet. So they still take a lot of time to reverse out the CAN signals to make sure that the M182 is replicating those. But luckily, they're not encrypted. So they're not quite as complex as like one of the C8 Corvettes, for example. So the design process for that is, you need to understand the OEM harness. You need to reverse out the CAN signals. So the CAN signals that the ECU needs to transmit to replicate the OEM ECU, as well as what it needs to receive from the BCM or from the ABS, wheel speeds or anything else like that. You need to have that. And then from there, it's developing a board that will take the signals from the OEM to the M182 or to the M1, whatever ECU you're going to use. And then from there, it's actually writing the software on the microcontroller to do some of that, turning off inputs and outputs based on a CAN message from the Motec ECU. Once you kind of have that all laid out, you actually design the board itself. So you need to actually sit in a software, Fusion 360, for example, or Eagle PCB or Altium or any of those, and sit there and actually draw out the schematic of the board you want. And then you need to take that, turn it into the actual components you want to use, place them on the board, run those traces back and forth. And then you need to actually get a prototype in-house. So you get the prototype in-house, you have to solder it all up. Usually we do that ourselves. Solder that all up, put it in a PCB case, and then put it on the car and start testing. So now it's, then you're at a whole validation stage where you need to verify that everything that you've done is not going to damage the car, is not going to hurt any of the outputs, that is not going to make anything else on the CAN bus angry. And then once you've kind of proven that, that's when you can go to production or version 2 board if you find mistakes or you find things that you don't like the first time around. And then from there, it's kind of into an actual sellable product that you can actually put out there for sale.
Okay, that's a lot of work.
That's one side of things. The racing side of things, I'd say, is a little bit faster paced.
Okay, well, let's continue down that example since you've just given it. Can you give us an idea? What's the sort of time frames from start to finish for that particular C7 product you've just gone through?
I would say for the first iteration for it was about maybe 6 months. Maybe about 6 months for the first prototype to be done.
And how many people are working on that team to get that product to a prototype?
I'd say there was about 3 or 4 of us. And it wasn't full time. So we have other things we have to get done throughout the day. So it's not like you can spend 6 months straight doing this. It's, I'm going to have an hour here, I'm going to have 4 hours here, 2 hours there, because you have other projects as well.
Yeah, absolutely. I'm interested to know with a product like the C7 Corvette, obviously there's an enthusiast market for that. So I can sort of see some benefit for GM in terms of having aftermarket support for that particular vehicle. Do you get any help from the factory when you're trying to reverse engineer a product like that, or are you just out on your own?
Typically, we're out on our own. Typically, they don't, not at least with Race Grade. I don't know about other companies, but at least with Race Grade and Motec USA, a lot of it was really, we need to find the pinout. We do all the work. We do all the sniffing of the CAN bus. We do all of the kind of reversing of the controls. So I would say that was a lot of us doing that one.
Okay. The other aspect with this is you've just mentioned 6 months with potentially 3 people working on the team, albeit not full time. That's a huge amount of resource going into this. So how does Race Grade kind of highlight a product where they can be pretty certain that the ROI on that initial investment of time is going to pay back Yeah, how do you assess the market size?
Yeah, so we wouldn't start a project like that without having at least a couple interested parties first. You would need to have kind of a sign on of either Motec dealers or different customers saying like, yes, if you develop this product, I will purchase one. I would love to have one. I'd love to have 5. I want to have 10. Whatever it is. But you have that minimum quantity, and it changes depending on the project. But you wouldn't start that without having kind of a sign off from the dealers in the network and the customers saying, yes, I am interested in this kind of a product.
Okay. The other element you've mentioned there is encryption. So talk us through how that's dealt with. Well, first of all, what that encryption means and how much of a problem it is for you, and what solutions there are around that.
Yeah, so with encryption becoming more and more, really what that is taking a CAN signal and manipulating it from what it's being actually sent as, and needing a key basically on the other end of it to decrypt that information. So it's kind of like if you're sending a message on your cell phone and it's an encrypted message, somebody else on the other end has to be able to receive that message, but you need to be able to decrypt that message to actually understand it. And doing that in nowadays cars is really, really difficult. On the C8, it's pretty impressive what they've done to kind of lock people out of being able to remove certain components, because the algorithm can change on any given day. So it can actually be something that you in the older cars, C7 for example, as long as you had that information, it was never going to update. So as long as you cracked it the first time, you could continually repeat that. With things like the C8, it's attached to a Wi-Fi antenna. So technically, it could beam down a different encryption code to its ECU, and it would change one day when you're driving. So if you put an aftermarket ECU in there and it changes it encryption, then okay, well now the encryption that you wrote doesn't work. So it's become a huge deal for that kind of aftermarket OEM switches being able to kind of work around those markets, because it's that one's a pretty hard one, I'd say.
Yeah, that sounds pretty extreme. So in terms of that encryption, are the OEs doing this purely to make our lives harder in the aftermarket industry, or are there other legitimate reasons around security and safety that they're doing this for?
Yeah, I'd say it's probably both. I mean, you've got like checksums, things like checksums and the decryption, which allows you to verify that the signal that you received from one device is actually what you expect to receive. So, if the checksum doesn't match what the bytes that you're receiving on that CAN message, okay, something didn't get received correctly, something got intercepted, something didn't come across correctly. So that's a safety issue, because you want to be able to understand that if you're sending throttle position, for example, and you're commanding something else, did I get the right throttle position message, or was that something that was kind of an irregular message and I shouldn't pay attention to it? So I think that's a safety issue. I do think part of it is locking people out from putting different modules on it, because I think, for one, GM maybe doesn't want the liability of that either, because if you put an aftermarket in the car and something goes wrong, whose responsibility is it? Because that could be a problem as well. So I think it's a combination of safety and kind of not wanting flashing and OEM replacements as often.
Okay. I don't want to go too deep down this side of things, but just because you've brought it up with the encryption on that C8 platform, and the platform is not brand new, obviously, by any stretch of the imagination. There's people going incredibly fast with that platform. Haven't kept up with sort of aftermarket solutions for that. Is anyone actually currently delivering a full standalone, or is it reflash only on that platform for those encryption reasons?
So far that I've seen, it's there's piggyback systems, so you can basically intercept some of the signals, and so you can get some of the control out of it. But nobody, I believe, has ever replaced the actual full ECU itself.
Okay, interesting. All right, let's talk about some of the other tasks while you're an applications engineer at Motec. You said you were involved in some of the race series as well, the likes of IMSA and etc. So what's that involve? What were you doing as part of supporting these race series?
Yeah, so when I first started out, Motec, there was DP cars running in IMSA, which is one of the series that races in North America, and it's everything from helping out with calibrating sensors on a dash or an ECU, to helping them diagnose issues or bugs they may find in I2 or Motec dashes, and kind of working with them to find solutions. It can be anything from doing full support for a weekend. I did almost 2 years of full support for Whelen Engineering and their DP program, where you basically, you're responsible for downloading data, you're responsible for making sure the sensors are working, you're responsible for setting up the telemetry system and making sure you're getting data coming across to the pit stand. For any wiring changes that need to be made or any wiring fixes that need to be made, you're responsible for that as well. So that's kind of one aspect of it. And then you can move all the way into doing, full series support. So in 2016, 2017, Motec USA did the full car support for the LMPC program, which had up to 9 cars basically, and we did the full electronics. So everything from the dash to the logger to the ECU to the interface with the gearbox controller, as well as the PDM, and we did the full wiring harness for it as well. So when I went to the track, I would actually work with the series to download the car data, the ECU data, to validate that it was actually nobody had messed with the calibration. Nobody had gained access to it. They were password protected, but people are pretty savvy, so they can work their magic. So a lot of the was making sure that the series understood that these 9 cars all had the same calibration loaded. They all had the same power levels, that no team was trying to kind of work around things or trying to get that extra power level. So it was a lot of that as well, and working with the series to go over the project, kind of keep them updated on what was happening, and kind of walk them through a weekend of kind of what that was like.
Sounds like a fairly broad range of tasks you're completing there. In terms of the sort of mainstream cars that people sort of might be familiar with, expecting to see at an IMSA event, maybe GT3, GTE, which is now, I believe, GTD. I can't quite keep up, but anyway, these are factory-built cars from the likes of Lamborghini, McLaren, Ferrari, etc. I would have assumed on face value no Motec electronics. And these, am I wrong?
Yeah, so I mean, back when I was working in it, they definitely had Motec data loggers. Not every car, it's really based on the team and their decision on what they wanted to run. But there was quite a few, Motec data loggers that were ancillary devices to kind of what the OEM was providing, because they wanted to run, extra inputs, or they wanted to do a little bit of a different control, or they just really appreciated Motec i2 software. So they definitely had quite a few Motec loggers in various GTD cars, GTLM, for example, the GT40, the Chip Ganassi Racing had quite a few Motec devices in that as well.
I think a lot of it comes down to, as well, the engineer that's doing the data analysis. A lot of it comes down to what you're familiar with. So if you've sort of come from a Motec background, chances are you probably going to want to continue using the Motec product, which in the case of the data analysis is their i2 Pro software. Is that sort of an element of those decisions?
Yeah, I would definitely say that the data engineer plays a good role in understanding and being able to have some say into what electronics may go into the car, especially if they've been with the team for a long time, or if it's a new car build and they bring in an engineer that is very familiar with Motec. They're going to say, hey, I've got a learning curve if I switch to Cosworth or Bosch or anything else, but if I go to Motec, I'm more familiar with it, so I'm going to kind of hit the ground running.
In terms of the skill set there, it sounds from what you've said that you're involved fairly heavily with the data acquisition side as well. So that's quite a specific and different skill set to the PCB design, can sniffing, etc. How did you develop that skill set? Did you have that prior to working at Motec, or is that something that you sort of built up while you're at Motec?
Yeah, for the data analysis side, I would say FSA got my feet wet in terms of being able to download data and kind of have a look at it a little bit. But in terms of really getting more in depth into a real car's data, I would say I just got thrown into the deep end when I started working at Motec. I think my 4th day there, I went to the Daytona Roar, which is the event before the 24-hour race. And I went there with my coworker and my boss, and they were like, all right, this team needs help, go help them. And so you're just kind of thrown into this. It's like, okay, let's take a look at this data file. Let's figure out what's going on. Let's see if I can figure out why the sensor isn't working correctly. And okay, this data log, I see a bunch of dropouts. Okay, maybe we've got a 5-volt issue, or maybe we've got a 0-volt issue, or kind of diving right into it. So I would say a lot of that is really learned through working at Motec. I didn't have a ton of experience doing my own data analysis on my own car or anything like that. I really learned on the job with a lot of help from my coworker and a lot of help from my boss, kind of, and a lot of patience from some of the teams on really learning how to analyze all of those sensors and how to find the issues.
As I see it, when you're considering a data acquisition system, the sort of 3 areas that that you can sort of analyze, I guess, in general. So there's the engine performance, and that's engine performance as well as engine reliability. Then there's elements of analyzing the driver's performance in any areas that the driver could maybe sort of start looking to improve upon. And then there's the chassis as well, that, you know, sort of how the suspension's working, dampers, etc., brakes, all of that sort of stuff. Were you working across all three of those areas?
I would say it depends on the year. When I was with Wheelin, I definitely got to do kind of everything. You'd be doing everything from trying to calibrate a gear pot sensor on the GCU, which is a Megaline extract box, but to everything from, you know, trying to calibrate a shock pot sensor for the damper positions, to everything from looking at the engine coolant sensor that seemed to be acting up. So you kind of really get to mess around with all of the different components on a race car in a team like that. When you move more into some of the other data support roles, you definitely can be a little bit more, kind of subsidized into what you're looking at. And so you may be only looking at kind of the sensors that are going directly into the data acquisition system, because you have a full-time engine engineer that's responsible for looking at all of the engine sensors, and you have, you know, extract support. So they're looking at some of the gearbox sensors and some of that data. So it really depends on, I think, the size of the team and kind of the level of the team as well. You know, you get a lot of club racers who you get to do everything, and then you get a lot of kind of higher level teams that, you know, often they'll have a bespoke person for different aspects of that.
Sure. Yeah, that makes sense. So it's obviously sort of horses for courses on that front. In terms of, you know, a complex data analysis package, or, you know, data acquisition system, I should say, where you've got a huge number of sensors. I mean, kind of circling back to what we were saying earlier, it can be quite overwhelming if you don't know how to analyze the data. In particular, if you're looking for a problem, it can be easy to lose it in a sea of different channels. And I'm interested to know what your sort of approach is when you first download the data and sort of start looking through it. You know, what are you looking for first? Are you basing what you're going to look for on feedback from the driver or the race engineer? You know, talk us through that.
Yeah, I would say the best thing that you can do is prep. So obviously to have like your workbooks, your worksheets, or whatever your analysis software calls them, already laid out, so that you have different tabs that you can go through and say, okay, this is my driver tab, this is my damper tab, this is my engine tab, so that you can quickly kind of flip through different tabs to see what the overall look of the sensors is. So I think sensor health is the first thing you look at. You know, are there dropouts? Is a sensor reading incorrectly? And then how important is that sensor? Because obviously, as you know, in racing, you have a practice session, and then you've got, 2 hours before you go back out again. So your time is very limited. So we have to be able to rank the importance of fixing sensors or fixing issues in order of what's the most important. What is engine stopping? What is race stopping? What is practice stopping? Versus what's something that's a nice to have, but if you run with a session without it, it's not going to be the end of the world. You can make do without that particular sensor. So I think a really good thing is having those different tabs, so you can quickly look through and say, okay, there's no dropouts, there's no major issues, the sensor hasn't pulled the whole 5-volt bus down, that's a major problem. But okay, the sensor is reading a little bit incorrectly, it's really noisy, okay, that's something I need to look at, but I don't need to fix in the next hour. I need to focus on this other aspect more.
Okay. The other element which can be quite useful when you're analyzing, maybe 20, 30, 100 laps of data. I mean, cycling through each of the laps, looking for maybe a maximum or a minimum oil pressure, coolant temperatures, whatever, for engine reliability. That in and of itself can be very time consuming, and also it's very difficult to find the specific lowest point for your oil pressure, for an example there. So I personally use in Motec lingo, channel reports to help with this. Can you talk us through what those are and how we'd use those?
Yep. So channel reports can kind of give you a big overview onto what your min and maxes are, or your median average, or anything that you're looking for on different sensors. So you can set up a whole list of sensors, and it'll go through and it'll highlight in red or in blue and in green and what your different high and lows are for the lap, and as also throughout the entire session. So you really get a full view of what your mins and maxes are. So you can see right away, my engine temp was way too high during this lap. Okay, now I can go through and look at that exact data. Or my engine temp was really high for these 5 laps. Okay, I need to look at that. But it gives you a kind of a really quick view of all the different sensors on if they've gone too low or too high. They won't tell you if a sensor is noisy. They won't tell you if a sensor is having small issues, but it will give you a quick, good overview on if sensor health is generally there.
A really good way to quickly identify any potential problems that you can then sort of zero in on rather than trying to scroll through all of the data to find what may or may not be an issue. Then you can find out from that min or max, maybe there were some circumstances around why that actually happened, and it might not be a problem at all, but definitely a huge time saver, correct?
Yes, exactly. I think telemetry has also really helped that, because now that we've got certain teams that have, live data coming through, you're almost looking at that live data before it even gets to be downloaded. So you can kind of see some of those issues beforehand as well. And, not every team gets telemetry because either it's outlawed by the rules or, the budget concerns or things like that. But telemetry is definitely also a good kind of precursor to looking at some of the data, because you can find issues there as well.
Yeah, absolutely. I mean, most series we sort of see at professional levels, telemetry is certainly not uncommon, and we've probably all seen the likes of Formula One teams sitting on the pit wall with an array of screens showing everything that's happening on the car. What's actually involved in getting telemetry data into the pits? How complex is that?
It can be pretty simple and it can be pretty complex. There's a couple different types of systems. When I first started, there wasn't anything that was 4G, so there was nothing kind of cell phone related based at that point. It was all RS-232 point-to-point 900 megahertz radios, which basically is just line of sight. So if your car can see the telemetry radio on the pit stand, you have great communications and you're going to get all the data that you want that you can possibly send. If you don't have any line of sight, so you've got a tree in the way, you've got a bridge in the way, you go over some hills, and so now there's a different change in your elevation. Okay, now you've lost a bunch of sensors, and that is one aspect. With 4G, obviously, you introduce a whole different aspect, because you don't have to see the sensor or the radio in the car or in the pits. As long as you have a connection to a 4G tower, okay, now you're in business. You can kind of run anywhere. So now you're relying more on what's the cell service and how many fans are FaceTiming during the race, and how many fans are streaming things live, which can really affect signal quality on a telemetry radio. And they get even more complex, where some of them end up having like two modems in them, so they can switch in between, Verizon and T-Mobile or AT&T or whoever, and can switch back and forth based on which has the best signal quality, because people are, streaming the race live in the beginning of it, especially, or throughout that. In terms of the car for telemetry, it's pretty simple. It's either an RS-232 signal or it's an Ethernet signal. There's an occasional CAN-based signal as well. But basically, you set up the telemetry channels that you want to send, you set the rates that you want to send, and then as long as you don't overload the bus, which you do have to be careful with on serial or CAN, Ethernet, you good bandwidth there. But as long as you can send the telemetry radio channels that you want, on the other end of it, as long as you've got that either 4G connection or that line of sight, then receiving it into that is really just, in Motec land, it'd be T2 server to be able to receive those signals and decrypt it. And on the newer data loggers, they have what you call metadata, which is something that you basically, when you load your config onto a dash, it creates a metadata file, and you need that metadata file on the receiving side to decrypt that logger information, which kind of puts that security in there so other teams can't, spy on your telemetry stream and see what you're doing, because you have to have that metadata file that laptop has.
Yeah, I can imagine security being a really big concern with telemetry at that level. So it's good to understand that. I don't know what it's like in the US or around the world. I assume much better than New Zealand, but one of the problems we often see is the cell phone coverage at racetracks is questionable at best. And then the point you made is exactly right. Maybe you have marginal cell phone reception or cell phone coverage, and then at a big race meeting with lots of fans, as soon as everyone jumps onto Instagram or whatever, anything you had sort of disappears. So is it a bit of a coin toss between 4G versus radio based, or is that line of sight too much of a problem?
I think the line of sight ends up being too much of a problem when you really get down to it, just because there's so many racetracks that have elevation changes. And, Sebring has a ginormous building on pit wall. So besides pit lane, you're not going to see anything else because it's all right there. So you end up having all of this other interferences. You've got now fans show up with tents and RVs and campers. And so you have a really big problem with line of sight at most tracks that are kind of not oval based. Ovals are definitely something that you can get away with more line of sight, because if you put your mast up high enough, you really can see the car going around the track most of the time. But when you get to the different tracks, I think 4G, even with the downside of maybe the first 5 minutes of the race having not the greatest signal, in the long run, you get much better coverage and you're allowed to send a lot more channels because you have that bigger bandwidth and you have that buffer. So I think 4G, wins out for now.
Okay. Now, does that then open the analysis up for setting up alarms on the pit wall for different channels so you can actually monitor what's going on with reliability aspects, maybe an example of tire pressure monitoring. Maybe you can monitor and have an alarm set up for a low pressure to indicate, maybe give a pre-warning to the driver that potentially he's picked up a puncture.
Yeah, absolutely. And I've seen that happen, that exact scenario. It's great. The driver has usually a display in front of them, but they're also focused on passing people and not getting past and, driving the racing line and kind of really putting their mind into that. So they don't want to focus on too many different things on the display because can be kind of overwhelming. So luckily with telemetry, you get back to the pit stand and you can set up all of those alarms and you can have a big red flashing light in your face saying, hey, this is wrong. You need to look at this. And I'd say for like a 24-hour race, that's probably your best friend, because at 4 o'clock in the morning when you're looking at things and your eyes are kind of going cross-eyed, having something that kind of bright red in your face say, hey, this is a concern is really helpful.
Yeah, definitely. I could totally understand that. All right, so you didn't stick with Motec for your entire career. You actually wanted to further your education. So talk to us about that decision and sort of what you were weighing up when you were deciding on this.
Yeah, I spent almost 9 years at Motec, so it's like a second home. It was a really hard decision to leave. Everybody there is really great. Everybody in Australia and in the U.S. office, they're great people to work with, and the really exciting thing with them is that every day was a new day. There was always a different project, a different racing series you're involved in, a different issue you had to solve. So it was always really exciting. But I really wanted to expand a little bit more of the controls side of things, and a little bit more into the programming side of controls as well. And while Motec gave a lot of that with M1 Build, where you can kind of custom design your ECUs for programming, I really wanted to dive a little bit more into other types of controls. So everything from, brake-by-wire systems to other different controls for EV machines. And I think Motec's definitely getting more into the EV market lately, but they're not fully there all the way yet. So I think being able to kind of get a little bit more knowledge on the hybrid EV things was really interesting to me. So I decided there's a master's degree program in England, and last August I decided to go over to England and give it 1 year of a master's degree to see kind of what that was all about and see kind of if I could broaden my horizon in a hybrid and controls aspect.
Okay, so what is the specifics of this master's degree that you are doing? What's it called?
It's Advanced Motorsports Mechatronics.
Okay,
which is a lot of big words.
that's a mouthful for us laymen. Maybe break that down into what it actually means.
Yep. So it's focused really on a motorsports aspect. Every class that you take has it's all to do with motorsports. So I think that's the big difference in your undergrad, where you're kind of doing this broad electrical engineering degree or kind of broad mechanical engineering degree or whatever it is. This is a lot more motorsports driven. So you're getting a lot into the motorsports program on how things function. The way it works is you do 8 classes for the first part of the year. So you do basically a week of class, and then you have a week of either a project or an exam, depending on the class. And that is everything from powertrains to vehicle dynamics to controls to data acquisition to vehicle kind of CAN bus configurations to hybrid kind of understanding as well. And what it does is there's 2 courses. I went to Cranfield University, so there's 2 courses. It goes Advanced Motorsports Mechatronics and Advanced Motorsports Engineering. And for the first 4 classes, we take those all together. So that's powertrains, vehicle dynamics, data acquisition, and business of motorsport, which you get a little bit of an understanding of kind of the business side of things. And then the last 4 classes we split. So motorsports engineering does things like, materials and more carbon fiber and more of an understanding of aero. And mechatronics splits and does a lot more on the MATLAB simulant kind of controls level of that side of the kind of programming. Once that's over, it's about 12 weeks, I'd say, you do a group design project. So that group design project is you're broken up into 4 teams. You design from the ground up whatever the professors have decided to throw at you. For us, it was a racing motorcycle, but you could not use regular fuel. So you had to use alternative fuels or EV or hybrid, one of the 2. And then they put a lot of restrictions on what that what that really meant in terms of what the amount of fuel you were allowed to carry on board. And it was an endurance race. So you had to kind of find that balance between the fuels that you're using, the hybrid that you're trying to use, the EV, and where that trade-off is in trying to run an 8-hour race on a bike in something like Spa.
Okay, I can sort of see the parallels with what's happening in the world with the move towards EV and hybrid and trying to make more efficient use of the fuels that we have got. I guess, where do you see that degree taking you? What's the sort of the long-term plan from here?
I think for me, I just got a job. I've only been at HP now for 2 months, but for me, that engineering degree really has allowed me to apply for a little bit more of a senior level role than ever I've had before. At Motec, I was applications engineer, but they're still kind of small company, and I never got the real chance to be a little bit more of a senior level role. And I think with the master's degree, with having kind of a little bit more knowledge on the control side of things and the EV side of things, that's allowed me to kind of take a step up in my career than I would have been able to have before. So at HPD, I'm actually applications group lead, which means I'm actually kind of helping to liaison with a bunch of different people in the applications group and the electrical wiring group, and get to make a little bit more decisions on processes and understanding the flow of how we're going to do things, and also really work with our electrical design and EV and hybrid team to kind of move the whole company forward in the kind of EV hybrid area, which is really exciting.
Okay. Let's talk a little bit more about this current position. So you've mentioned HPD, fairly well-known name, but for those who maybe aren't familiar with it, can you tell us what HPD is and what you do?
Yep, it's Honda Performance Development. We're out of Santa Clarita, California, and I'm the applications group lead, which is basically there's about 7 engineers that I'm working with that I get to kind of help with their projects, help to make some of the decisions, and also work with my manager, who's the electrical group lead. And there's kind of 4 team leads. So, we've got 4 different members of the team all doing different aspects of the electrical side of things, kind of all working together to make one big electrical group that kind of is moving HPD further into the hybrid and EV market.
Okay. So you're moving towards that market, but what current sort of genres of racing are HPD involved with? Where would be likely to see HPD racing?
Yep. So IndyCar is probably the biggest one. IndyCar has just 2 different engine suppliers, Chevy and Honda. So we've got more than half of the field currently that's running a Honda engine for IndyCar. So Indy 500 or any of the other races that happen throughout the year. So that's a really big one for us. Currently, we have our DPI program, which runs in the IMSA field, which is 2 cars that are currently running. That ends at the end of this year, and then LMDH takes over, which is Le Mans Daytona hybrid, which is basically the one of the first things that Honda will be running in a racing series that has that hybrid aspect to it. Beyond that, we have the NSX that also runs in IMSA in one of the lower classes, and then tons of different TCR classes and SRO Civics that run in those series as well.
Okay. Can you talk to us a little bit more maybe about that LMDH series? So talk through the engine and the hybrid element of that.
Sure. So it's a Honda engine. The hybrid element it's spec across the entire LMDH paddock. So it's actually something that was spec between IMSA, Bosch is involved, Williams is involved, and that is kind of a hybrid system that's allowing it to interface with the engine and allow it to give power to the rear wheels in a hybrid aspect. And that's going to be all kind of down to the different levels of what IMSA allows the different teams to run, but every team has to run the same kind of hybrid pack setup.
Okay, so you've got the same hybrid pack, so there's a consistency across all of the teams there. I get that makes sense. Is the flexibility in terms of your control strategies and how you're going to employ that hybrid element? Is there a way of sort of differentiating yourself amongst the competition in that side of things?
Yeah, I think there's definitely some ways that we have some flexibility. Like luckily the ECU control is really left up to the the different teams. So we don't all have to run the same engine controller, and we don't. So you get to have some of the kind of the strategy built into the engine controller, which is really interesting because that means you get to develop some of those control strategies as well. But there are also limitations because it's, because it's IMSA or any racing series, they have limitations on, how much you can regen, how much you can, deploy, how much you can use per lap. So there are definitely limitations and things that you have to play within the rules, but it does leave, markets where you can kind of explore the different aspects of interfacing with hybrid.
And in terms of the driver involvement or control of that, how much of that is up to the driver, the different modes for sort of regen and deployment, or so that the driver can maybe utilize a little bit more hybrid power, maybe for, essentially, I guess, a push to pass or something of that nature versus defending. Can you tell us a little bit more about that?
Yeah, I mean, you basically hit the nail on the head that there are, the option to do different kind of modes where you can use a little bit different tuning methods on how that's going to deploy or how that's going to regen. I think a lot of that strategy is still being kind of fine-tuned now because we go racing in Daytona in January. So we're currently doing lots of testing and lots of kind of development on that right now. So I wouldn't say we have it 100% nailed down. It's definitely a full development process. And I think we'll still be developing, as the racing series starts, because luckily it's not locked down. So you do get to kind of play with that throughout the entire season to kind of fine tune that at different races. So maybe you have Daytona, which is going to need a different strategy than Sebring, or is going to need a different strategy than Watkins Glen. So I think it's kind of a continually evolving project where you get to kind of add those aspects here and there and get to fine tune for the exact track that you're going to be at.
Talking about the engine side of things, the internal combustion side of things there, what are the limitations placed on that? I mean, are you stuck with an inlet restrictor or something like that for some kind of power parity, or what's the...
It's basically based on like BOP. So you've got the BOP that IMSA sets out. So you've got a high amount of horsepower that you can have, a maximum amount. They're also looking at things like lambda sensors. So, oftentimes they're not going to let you run too lean, too rich. So they're looking at those. They're also looking at boost pressure. So if you've got your boost pressure, you can only go a certain amount of boost pressure while you're on track. And if you go over it too many times in too many amounts of seconds or too short of a time, you can get a penalty, or you can get, dinged for that kind of behavior. So you really have to fine tune within their limits of what the BOP is set. And that can also change race to race. You may have one weekend where the BOP set one level and the next race it's slightly adjusted, either with adding ballast weight or either with adding different power levels or a fine tuning kind of what the different aspects can be.
Okay, I'm interested on that balance of performance side of things, how well that works out. I mean, I was involved for a period of time here in New Zealand with a engine parity matched series that used a control chassis, but bodywork, etc., was different based on the manufacturer of the car. And the 4 seasons that I was involved with, it was just a continual battle between the teams. No one was ever happy with the parity. Talk to us about balance of performance, how well that actually works. Is it the same scenario that whoever's getting ballast added or their engine performance limited is unhappy, or is it pretty well accepted and it works well?
Yeah, I think there are times when it doesn't work the greatest, and I think but there are times that I think it really does do its part. And I think that no matter what you're going to have, is that you're going to have, every team's going to try to get the most out of the performance that they can, and every team's going to want to say they have more power than we do because they want to have that little extra BOP for the next race. So I don't think it's always a straightforward answer on terms of that. I mean, you can see that in the F1 paddock nowadays too. It's, it's like, they have more power. No, they have more power. And everybody's trying to get, the regulating series to give them a little bit extra. And I think that's across almost every series with a BOP. So in terms of limiting, boost pressure and limiting horsepower and things like that, I mean, they have sensors on there to actually physically monitor what's going on. So they have a pretty accurate system to know, when we're going above, when we're, right on target, when we're too low, anything like that. And they're pretty diligent about, that it's pretty hard to cheat the system. So I think it's pretty accurate on the data that they're getting. Obviously, if we could all have as much power as we wanted and just go racing, I think it'd be awesome, because it'd be, a fantastic display of the capabilities of HPD and of every race car. But I understand as an aspect of being a viewer of the sport, that if you let that happen, you have budgets run away, and you do have teams that can't keep up, or you have, downsides to it on the viewership side of things. And I think you see that in F1 too, that, but big budgets do a lot. And so I think I understand part of it, but I also, in the racing heart of you, you really want to be able to just go nuts and be able to do whatever you want to the car.
Yeah, I think that's the engineering sort of passion versus what the spectator sees, because, I mean, ultimately, and F1's a really good example of this. I mean, the current cars are slower than the last generation of cars, but I mean, yeah, as a spectator sitting on the side of the track or more likely watching on our TV, you can't see that until the actual lap time comes up. And what we want is tight, close racing. In the start of the hybrid era, right up to 2021, basically you watch two Mercedes sort of sail off into the distance because they managed to really nail the engine formula and just outclass the rest of the field. So that's from a spectator perspective is definitely not that exciting to watch. So I think done right, the balance of performance, it makes a lot of sense. I'm interested as well, just in terms of, I can only imagine that aids reliability for the engine life expectancy, given, I mean, that it's obviously not running on 10/10ths absolute kill.
Yeah, exactly. Yeah, if you have that limiting factor where you can't go crazy with boost, then obviously you've got that longevity in the sensor, and I think that's really important with endurance racing, which is what LMDH is all about. Is you've got a 24-hour race, you've got a 12-hour race, you've got a 10-hour race. So all of this long-term racing that you really have to make sure you can survive 24-hour race. And not only that you can survive, but you can match your competitors and survive. So I think having that reliability is definitely key, and definitely not being able to kind of push the limits at every second, not like a drag racing application where you got 8 seconds and if the engine blows up at 9, you're fine. This is, you have to last 24 hours. And even in some of these races, you have a limit on the number of engines you can run in a series in a year. So if you hit that 5th engine, just like in F1 too, okay, now you've got a penalty because you took on that 5th engine because maybe you weren't playing it as safe as maybe you should have been.
Yeah. I mean, the old story has always been to finish first you must finish. So it doesn't really matter how much power you're making or how fast the lap time is. If you don't get to the last lap, then your chances of getting the checkered flag are always going to be 0. So I think that's something that is easy to overlook, particularly for endurance racing. The elephant in the room here, I guess, Hannah, is the fact that you are a female in a male-dominated industry, and I wanted to dive into that a little bit. I mean, you're the first female guest that we've had the pleasure of having on the podcast. Does it make it difficult making a name for yourself in the motorsport industry being a woman?
I would say I'm the first female engineer that Motec USA has also ever hired. So I was definitely the odd one out when I showed up. But I would say that it really depends on the team and the people that you work with. One of my first tuning jobs didn't go as planned because they basically wanted to refuse to hire me because I was female. And that was kind of a little bit of a shock to me. But then I actually showed up for the job. I did my job. And at the end of it, he said, I don't want to work with anybody else. So I think you really can change people's minds. And I don't think everybody is like that at all. I've been to some fantastic race teams with supporting their teams, and being female wouldn't have mattered at all. It wasn't even a thought in the room. And then obviously there's cases when it definitely does matter, and you are treated a little bit differently in certain situations. And it's not always in a bad way necessarily, but you notice that it's definitely different in certain aspects. But I think nowadays, when I first started, there weren't a lot of female engineers at the racetrack. I didn't see hardly any. But nowadays, I'd say there are definitely more of them out there. You see more of them per team, or more of them, at the track in general. So I think it's definitely becoming more of a commonplace to see women in racing and to see them kind of succeed and to be able to step up to the next level and to take those roles and to work with a male-dominated field and really not have any issues based on gender.
I mean, we'd like to say that there shouldn't be any barriers based on gender, but unfortunately that's not always the reality. I do think kind of what you've said there, just the 20-odd years that I've been involved in motorsport, and obviously certainly nothing at the level you're operating at, but I think there has been a shift in maybe mentality, and maybe not across every form of motorsport, but as you say, you're seeing more and more women get involved at all different levels, which is really great to see. Would you say maybe there's any advantages then in being female in the industry?
I would say you stand out a little bit more. I mean, kind of obviously, I'd say when you go to the racetrack, especially for me, meeting a lot of men in the racing industry, I had a hard time remembering everybody's names, but I do feel like it was a lot easier for them to remember mine because there aren't that many, women. So Hannah's, something you kind of can remember a little bit easier. So I think you recognize that face more often, and you get that advantageous part of it, of that you're noticed more at the racetrack in terms of people remember what you did. And so maybe that helps making a little bit lasting impression, especially if you're good at your job, that, hey, I remember her a little bit easier because she's, it's not very common to say woman, but I also remember her because she did a good job. So I think you kind of get that a little bit extra advantage because you are a little bit easier to spot in the crowd.
Yeah, fair enough. That makes a lot of sense. All right. You said you've only been at HPD at this point a couple of months, I think it was. So is this a long-term sort of move for you?
Yeah, I definitely think that this is a company that's growing. It's growing in the right direction. They've got really exciting projects. LMDH is a really exciting project. IndyCar will be going hybrid in 2024, and there's further projects coming in the pipeline that are hybrid as well. So I think this push for EV and hybrid is a really exciting aspect for me, and it's one of the reasons I wanted to do the master's degree, is to get that exposure to hybrid. So now I get to actually get my foot in the door and actually start working on some of these hybrid systems. So I think for me, this is a very exciting time to join HPD in terms of what their project list is, and then also what their goals are in terms of a company, long term. So if they're going to grow in their electrical department, and I get to be a part of that growth and kind of maybe shape a little bit of what's happening, not a huge role, but a little bit of what's happening, that's also exciting and kind of an interesting step in my career as well.
Yeah, it makes a lot of sense. Obviously, the skills that you've put together perfectly align with where HPD sounds like it's going. I'm interested in talking a little bit about sort of the EV versus hybrid element. Obviously, no big surprise, EV is starting to gain a lot of momentum. But in terms of a motorsport application, we're not really seeing that. I don't know if I'm 100% right here, but I sort of sense that maybe at the moment battery technology and battery sort of capacity is maybe a limiting factor for full EVs in motorsport. Obviously, particularly it becomes an issue with endurance type racing. Is this why we're sort of seeing more of a hybrid element to an internal combustion engine rather than a direct jump to full EV? Or am I off the mark here?
No, I think you basically hit it spot on, is that, battery technology is definitely improving, and the better that we can control the batteries and understand the state of charge and how the batteries are actually able to deploy and recover, and those life cycles of those battery cells are really important. But I think the weight of the battery pack gets really, really heavy the more cells that you add, and the more cells that you add, obviously the more power and the longer they can last. So you have that trade-off of, okay, I need to make a really, really heavy car, but now it's so heavy that my battery is draining faster. So you have to have that trade-off. And then, having a battery last, 24-hour race just isn't really a possibility right now. So you're not going to have a battery last a 24-hour race and have the good amount of power that you want to see on the track. I think also a limiting factor of EV is the sound. I think a lot of people show up to the racetrack and they want to hear that engine. They don't want to hear just wee, they want to hear that full, engine. So having that there, I think, is really important. I think what you'll start to see kind of an engine become a little bit more of the push to pass, and the hybrid become a little bit more of the main component. So you still have that sound, you still have that excitement of the engine noises and kind of what the racers, especially the older generation, want to hear. But I think you'll also have the hybrid becoming a bigger part of it as well.
Yeah, the sound of the full EV is a difficult one. I mean, it seems like such an irrelevant aspect, but you look at the likes of F1 and the move from the naturally aspirated V8s, V10s, and V12s, that sound that everyone who was a long-term follower of F1 grew to love, and then the modern era with the hybrid V6 turbo, and I mean, they just sound flat and boring, unfortunately.
Yep.
moving to full EV and listening to essentially radio controlled cars go around a track is certainly not something that appeals to me, but I'm also, my eyes are open enough to know that is ultimately the way we're going. So I'm not sure if there's a solution there. We'll just have to maybe grow to love it. I don't know. It's difficult as well when we go to, I've been to the likes of Pikes Peak a couple of times, and not only do the EVs not have a great internal combustion engine sound, but they go one step further because they don't make enough noise, and they force them to run a siren to warn people that they're coming. So I mean, it just goes from bad to worse. Back to the battery technology. How many generations of battery technology away from realistic use of full EV in motorsport are we, do you think? Looking into a crystal ball.
I think in short-term racing, so in short racing, I mean, it exists. You can do short battery races. There are Moto E, which runs in Europe, which is a motorcycle race, but they're 20 minutes long. So if you want it to be full endurance racing, I think there's quite a bit more work to do, because it's not only about exploring different cell combinations. There's so much involvement right now into different combinations of chemicals. So, and I'm not a chemistry engineer, so I won't be able to dive fully into that, but the different understanding of the different battery chemicals that you can use within a cell and how that could potentially make a longer cell, make a higher powered cell in a smaller package is really exciting. But I think there's so much more investigation and testing that needs to be done before we're there, that I don't see the endurance EV racing very soon. I think that the regen is also the big thing. You have to be able to recapture that energy in braking, and putting an electric motor on the front to regen that braking effort is really important, but it does add a lot of weight as well. So you have to kind of get that right. And then motors are not, they're not light, and they're not necessarily compact. So how do you fit that into a different engine package? So I think we're quite a way off of a full endurance race battery, but I think the technology is rapidly improving to get there.
Oh, look, for one, I'm certainly not going to be disappointed if internal combustion and hybrid combinations become the norm for the foreseeable future. I'm absolutely down for that. But it is exciting. There's a lot of development there, obviously, and it's not difficult to see the way things are headed. But maybe a few challenges still ahead.
I think you should also maybe everybody should look into like alternative fuels. So there's a lot of research right now into doing different alternative fuels, which means you get to keep your IC engine, but you get to do it in a little bit more of a sustainable way. So the power levels are different. The tuning is very different. You're aiming for different things. The different fuel rails and things you'd have to implement are different. But I think alternative fuels could definitely be a way to keep that internal combustion relevant, with also making it a little bit more environmental, a little bit more sustainable, which is what a lot of series are aiming for. They want that sustainability aspect so that they're not impacting the environment as much, but they're also getting that exciting racing feel.
Are we talking here the likes of ethanol-based fuels?
Or hydrogen. Hydrogen's a big one right now.
Hydrogen, okay.
Yep.
Yeah, I have been interested. It's not something that I know a lot about, so I can't talk sort of too in depth, but I have sort of wondered why hydrogen hasn't really taken off. Is it sort of the issue with storing the hydrogen, or
yep.
Are there other issues around this?
No, it's a lot of the storage issues, and it's a lot of safety issues. You have to be aware that hydrogen for storage it takes up a lot of space, which means that you can't run it on it takes up a lot of space in terms of you can't run on a bike, you can't put it in a car without having a lot of the back end dedicated to that kind of storage. So you need to make sure that you have that kind of capability. And then it's also the safety aspect of making sure that you don't have a very high pressured tank of hydrogen. What happens if the car catches on fire? What happens if anything that? So that's kind of the biggest safety factor of it. And they make tanks nowadays that can withstand 2 minutes of fire, and with hydrogen inside at 700 bar, and they're capable, but you still can only get a little bit amount of hydrogen out of that tank. So you'd have to have 20 of those to really make a long endurance race. And then how do you package that in a car? So I think hydrogen's got that fuel density aspect to it, but it's also far from the ideal necessarily fuel for racing.
Yeah, I like the idea of being able to continue utilizing the engine technology that we've already got developed and just changing to another fuel. I think that makes sense. And obviously hydrogen in terms of its environmental impact, way ahead of any gasoline or alcohol-based fuel. So yeah, I think that sounds to me like there should be some potential there, but obviously the challenges that you've just mentioned. Ultimately though, unless I'm missing something here, I'm guessing almost irrespective of the fuel that we're using, internal combustion engine, the efficiency of the way it converts the energy and the fuel into power is never going to come anywhere close to an electric motor, correct?
Yeah, that'd be very impressive. F1 touches at like 50% efficiency with all of their electric hybrid components involved as well, and they're kind of the peak of what I'd say the efficiency is. Obviously, they're pushing the limit, so I'm sure they're going to keep pushing past that. But to get to an EV level, that'd be a pretty big jump to make, and I don't think we're going to see that anytime soon, at least.
As I understand it, we're talking efficiencies somewhere above 90% for EV, and maybe a normal road-going engine in the 30s. Is that about right?
Yeah, I'd say road going 35 would be nice, up to 40 if you've got some good aspects. F1 closer to 50, but yeah, EVs kind of knock it out of the park there.
Yeah. So not even comparable. Yeah. All right. Look, been a really interesting chat with a very wide range of topics in there, Hannah. We appreciate your time, and I do want to respect it. So we'll move towards wrapping this thing up, and we've got the same 3 questions we like to ask all of our guests. The first of these is, what's next in the future for you and HPD? I guess we've probably touched on some of that, but any other elements you want to maybe chuck into the mix there, Hannah?
Yeah, I mean, guess because I'm brand new, it's kind of the sky's the limit for where I hope I can go with an HPD. I definitely want to stay there for a long time. I'm hoping they'll keep me on. So I definitely would like to see my department in the electrical group just continue to grow and continue to take on projects that are just more exciting and more challenging, I guess. So that's where I hope I am. Okay,
sounds good. Next question. Well, we're going to turn this around. Normally I ask, what advice would you give to a younger version of yourself to maybe fast track where you've got to in your career? But maybe we'll flip this around a little bit and say, what advice would you give to maybe the 3 female listeners we might have? I'm not too sure what our demographic is, but any female listeners that are looking at pursuing a career in the motorsport industry.
Yeah, I'd say, apply everywhere, apply to everything, get your hands dirty either with FSAE or with volunteering with a team or doing your own tinkering, whatever you can do to get that experience. And I would say, don't be afraid to, voice your opinion, if you think that you're correct, and to say what you think is the best route forward. If you don't know what you're talking about, don't just say anything. But if you have an idea and you think it's a valid one, I wouldn't be afraid to speak up and really put your opinion out there, because you may have that great idea that somebody hasn't thought of before. And I don't think you should be reserved as a female or as anybody to kind of try and to see if you can make an impact on that racing team. Yeah, perfect. Makes great sense. Last question for today, Hannah. If people want to find out more about what you're up to, is there anywhere that they can do so, social media, or do you like to keep to yourself? I'm not too sure. Yeah, absolutely. I'm more of a follower than I am a poster, but I am on Instagram as westbrook.hannah. So if you want to follow me or see what I'm up to, I occasionally post, racing things. Can't post too much about HPD because obviously it's a lot of internal stuff, but happy to reach out to me if you've got questions, or, if you're a female engineer and you want to know anything about it, happy to answer those too. So happy to talk. Perfect. We'll link to your Instagram in our show notes as well. Look, Hannah, great chat. Really appreciate your time today, and really interesting to get some insight into your career. Sounds like some really big things in the future for both you and HPD. So really excited to see where that goes to. Thanks again. Yep. Thank you so much for having me. If you enjoyed this episode of Tuned In with Hannah, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Brad from Canada, who has said,
just plain awesome. The amount of in-depth information on your podcast is astounding. I never miss an episode. Keep up the good work, and I'm looking forward to learning more on how to safely get all of the fluffy unicorns out of my own projects. Now, if anyone's listening and wondering what is the reference to fluffy unicorns, well, you'd better get involved with our back catalogue of episodes, because I promise you it's explained in there. Thanks for your feedback, Brad, and if you can get in touch with your t-shirt size and shipping details, we'll fire a fresh tee straight out to you. All right, that concludes our interview, and before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpaacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpaacademy.com/courses.